I work at a company called TrueSec that you might have heard about. I spend my time developing and auditing security critical systems. And if you don't know what I look like, that's me right there. So, oops, no, that's me over there. Yeah, we all want to be that good-looking guy, but we can't. Okay, anyway, let's get started. So yeah, security, it's important. You know, you have to remember to put on your tinfoil hat, talk about security with your kids, have the talk, so to speak. But it's also important to have it in your development project, of course. And the thing with security, it's like testing. You can't just tack it on at the end of the project. It has to be an integral part of your development. And therefore, today I'm going to be talking about some concepts and patterns that will help you in your daily coding activities. So specifically, I'm going to be talking about trust as a general concept. We're going to be talking about a pattern called domain-driven security. There's another pattern called the Untrusted pattern. I'm going to be talking about immutability, which is the opposite of mutability. Immutability means that something can't change. A mutable thing can change, and immutable cannot change. And then we'll finish off with the so-called inverse life coach pattern. All right, so let's get started. Trust. The foundation of software security is trust. Yes, it is. Trust is a super important concept when writing secure software, because a lot of security issues in code boil down to a poor understanding of where we or our software is placing its trust. Like, how do we control who we trust? Would you trust that guy, for example? How do we establish the trust? So if we just look at a typical interaction here, we have businessman Bob here who's talking to the bank, and he wants to transfer X euros from account Y to account Z. And sure thing, go ahead. So, you know, and this is a typical interaction that you've probably done yourself. You have an authentication step, you have some sort of transaction happening, and an acknowledgement of this. So, you know, what could possibly go wrong in this scenario? Well, just let's take a look at the first interaction here, the authentication step. How can the bank be sure that Bob is Bob, and how can Bob be sure that the bank is indeed the bank? Do we know that we're talking to the correct party from either end? And the actual transaction, the actual thing we want to do we know that Bob owns account Y? Does he have the authority to transfer money from that account? Do we know that account Y holds X euros? And in fact, do we even know that X is a number, or is Bob trying to transfer A euros, or, you know, whatever, a string? So, you know, Bob could really screw the bank here, or the bank could screw the Bob, you know, whatever side you put yourself on here. And so what you need to do is to talk about trust, and let's try to visualize trust. And a good way to visualize trust is the circle of trust that I'm sure you've all heard about. And as an application or an API or whatever, we have all this stuff that's outside our circle of trust. So we have the user, very untrusted party in this, the whole system here. We have request data, the database, services, etc., etc. And so what we need to do is to understand and identify where the trust boundaries are in our code. So just to really hammer home this point, and let's see if I can burn your eyes out with this slide here. Yeah, so everything outside the circle of trust is untrusted, and everything inside is trusted. And there are some important things to notice in this simple picture. You see how much smaller the trusted area is than the untrusted? And it's also bounded, it's well defined. Whereas the untrusted is infinite, it's everything. So you might want to remember this picture when we talk about blacklisting and whitelisting, why whitelisting is better than blacklisting. I'll get back to this later. So, okay, so how does something untrusted become trusted? After all, our application must interact with all this red goo, otherwise it's quite the useless application. Well, it does this by your favorite thing when writing software, validation. Yes, we love it. We love writing validation code. It's the most fun thing to do, right? It's so much fun, so you put it everywhere in the code. You love it. Some of these patterns are going to make validation easier for you. So I know this is not the funniest thing to do. But so, okay, you validate something and either it passes validation, it becomes trusted, you're inside the circle, it's all good, or it's rejected, bounces off. It's not allowed inside the circle of trust. Some more specifics about validation. You have what you typically think of validation is you validate that something is valid in your domain, like X euros, X has to be a number, it can't be A, or -1, you can't transfer a negative amount perhaps. Now, validation has some friends with fancy names, canonicalization, I think that's C18N if you're really cool, and normalization. And these are things that have to happen before validation. Take a look at that example of a file path. Now, when the file system interprets this path, or the OS does, it will collapse it to the path there, secret/keys, which is might not what your application expects. If you validate that this file path starts with, oh yeah, it starts with C public file upload, so it's good, I'll let my user upload a file there, boom, you're the victim of a so-called path traversal attack. So that's normalization. Canonicalization is when you just restructure the data. It's lossless, like you restructure it to get an exact format, typically when you do XML validation or digests, and you want to make sure the data looks exactly the same. There's also sanitization, which is when you clean up dangerous or unknown data. A typical example of this is when you write something to a log in your application. Maybe you get an exception and you write, the user supplied an invalid value. You write this to your log and just put the value in there. Well, now this is a user-controlled value. What if the user puts a new line in there and a whole new log entry? Maybe the user sort of knows what your log looks like. Then he can inject log lines into your log, which you might think, doesn't matter, I'll see that when that happens. Well, what if you need to use your log in a court case, for example? You show here, yeah, we can see that this nefarious activity has been going on, and then the other plaintiff can say, well, you know, I can actually inject stuff in your log, so it can't be trusted. Well, so it's a good thing to clean up your log data before writing it. Yes, some final words about validation. I mentioned it before with a red and green image. Always prefer whitelisting over blacklisting. Whitelisting is when you specifically say what you allow. Blacklisting is when you specifically say what you don't allow. And you remember how that red area was unbounded and so much larger than the green area? Well, try to enumerate everything in the red area. It's impossible. Whereas in the bounded circle of trust, the green area, that's where you can do your whitelist of the stuff that you allow. So if you can do whitelisting, sometimes you can't. There are some cases when you have to do blacklisting, but then know what you're doing and prefer whitelisting when you can. There's another thing about validation. It's not only for security. It also, if you're really strict about validation early, you can find bugs easier. Because imagine if you get some value input here in your application, you go 8 steps down, you're way deep inside in the internal bowels of your app, and here you get some strange exception because of this value that was wrong here. So you spend like 3-4 hours backtracking, trying to understand what happened, and you figure out, I was too lax in allowing a too large range for this value. So had you just been stricter there, you'd have caught it right there, and you'd have saved yourself a half a day of trouble. So validation, you might think it's boring to do, but it's super important, and we're going to look at some patterns that make it easier for you also. So the final thing, what you want to do when you're thinking about validating something, you just think, okay, what is the largest acceptable range for this parameter? And do not accept any more than that. Don't try to be nice. That's basically it. Like if this string that's coming in is supposed to only be lowercase A to Z letters, well, you know, only allow lowercase A to Z letters. Don't allow underscore or a dot because you think that sometimes maybe in the future this will be necessary and then I won't have to redeploy if I put it in here. No, don't do that. Just try to limit it as much as possible and then update it as your application evolves. Sorry. Okay, so that's trust. We've discussed trust in general. The foundation of software security. So let's move on to the first pattern. So this is called domain-driven security. It's a pattern that helps us with a trust boundary, and it gives us validation everywhere in a good way, in a non-friction way. Is there anyone from Omega Point here today? There's the inventor of domain-driven security. I feared that this could happen, so now you can really scrutinize if I got this correct. So here's the inventor of the domain-driven security pattern. What's your name? Okay, John Wilander together with Don Berg Jonsson. All right, thank you. It's an awesome pattern, use it a lot, and it's great. So let's see what that is. So let's look at Bob again and the interaction here. Here's Bob, and well, the bank, they've met before, right? They've already been validated, so the bank trusts him, and but now Bob does something mean. Does anyone see what's going on here, what Bob's trying to do? Yeah, like a negative €1,000, right? And the bank's like, fine, you know, I validated you before, I trust you. Ka-ching! Bob gets 1,000 kroners, in fact, in his pocket right there. So the thing is with validation is it has to be performed over and over and over and over again. So of course it's then easy to forget to validate somewhere. And the thing with this code is that it ends up everywhere, validation. But even though it's everywhere, it's easily forgotten, or perhaps it's actually because of this, because you can't see the forest for all the trees, right? And it's also easy to forget like where your trust boundary is. You need to validate even from sources that you don't think can be untrusted, like your database. Maybe you think, yeah, I control the database, it's in our system, you know, we only have our own data in there. Well, you know, somehow someone can sneak a mean value into there. For example, stored cross-site scripting, like someone has managed to put a script, a little script thing in your database. Some other user loads your page and gets that script executed in his or her browser on his client. So, and it's then compromised. So, back to the circle of trust here. With just regular validation of primitive and generic data types, you can be fine. You know, you validated, they're green, you're all good. But the thing is, when you're inside your application and your circle of trust, you cannot look at a variable. If it's a primitive type, you cannot look at it and immediately see that this is trusted. I trusted it. This has gone through validation. So what domain-driven security does is that primitive data types and data structures are untrusted by default. If you see a string or an integer, a byte array, or a date, you know, whatever built-in type you have, if that's floating around in your application, passed between methods, public methods in your classes, you know that's untrusted. Instead, you work exclusively with domain objects that have built-in validation, meaning that they cannot be created without first being validated. If a validation fails, you do not have a domain object. So let's take a look at that, what that looks like a little bit more. We have the trust boundary, circle of trust again, and the previous example will instead look like this. So our string will have been translated into a properly validated account object, and our integer will have to become an amount object instead. And because these are domain objects, we know by convention that they're validated, and therefore we trust them. So when you use domain-driven security, you automatically get data validation everywhere, not only in the places where you think that you need validation. So here's an example of a typical domain object, and you see what happens immediately upon construction is that we validate it, and if it's not valid in our domain account numbers are 10 to 12 letters long and then numeric. So if they're not valid, we throw. So we cannot construct this object at all with invalid data. So, like I said, this is by convention. You must remember to do this validation in all your domain objects. But after a while, of course, it becomes second nature. And if you see a domain object that does not start with a validation and throwing exceptions, then you know you forgot it. So it really pops out. So just look at a web example here. You have a web service. You're inside your circle of trust. There's some SOAP data with integers and strings and byte arrays and other, you know, nasty, untrusted stuff. But, you know, you pass the trust boundary, convert to domain objects. Maybe it's a user object, some sort of time span, account, etc. Whereas if you have some invalid data, it will just bounce off as an exception, and, you know, you don't have to worry. You can be happy in here. And the good thing with this pattern is that naked primitive types really pop out. So let's take a look at this function. The function reticulates, it takes a spline, and it reticulates at some angle. And the spline is a domain object, it's our object, so we know if the developer has done his or her job right, it has been validated. But what's up with this little thing here? Angle, what's that? That's an integer. What kind of angles do we allow in our domain? Do we allow negative angles? Do we allow angles that are more than 360 degrees? Should it in fact be in radians, for example? Should it be a float instead? You know, there's 1,000 things that then this reticulate function would have to validate first before even getting to work on this reticulation. And so of course we should do something like this instead. We should make a proper domain object out of angle. So in our domain, an angle is a proper domain object which has validation that checks that it can't be negative or whatever the rules we have for angles here. So I chose this example just to highlight that something even as trivial and simple as an angle, that's, you know, it's very tempting, just an integer. It also needs validation, and it deserves its own domain object, if you will. Then. So, and why not? It's easy to do and it's cheap. You get validation everywhere. So I can very much recommend this this pattern. So I'm going to reiterate the essentials of domain-driven design security here. So the type system ensures that the correct domain object must be used. It's not just an integer or string that can be whatever whatever it is, but you have to have the correct domain object type. And you know by convention that all domain objects are valid because you did that validation step before it was even in the constructor of the object. And yeah, sure, you still have business rules, right? Even if in our reticulate spline example here, are we even can actually splines be reticulated? Is this spline allowed? This is a business rule, you know. This angle might be a valid angle in our domain, but it might not be valid for this particular use case of this particular business scenario. So even though you don't have to worry about the building blocks being invalid. So you still have, of course, have business rules that you have to validate, but the building blocks will be fine and you can trust them. And you know you forgot to validate something if you see a primitive type being passed around, like a string or an integer, being passed around through the public methods or in your domain. Yeah, so also one more thing before I leave the domain-driven. It doesn't have to do with domain-driven security per se, but I'm just trying to shoehorn it in here. What about null? Right, the null. What do you do with null? So the important thing is never let null carry information. So what do I mean by that? Null is an error. Null is an invalid pointer. You should never use null in your code except for when you should never see it except for when you do null checks in the constructors of your domain objects, for example. So what was the typical thing that we see here? Well, if a value doesn't exist, oh, I'll return null. You know, I try to get the user, no such user, I return null. Don't do that. Do something with an optional, for example. This is available in Java 8. You can construct it easily in C#, for example. How many Java programmers in here? Hands up. All right, C# or .NET? Everyone else? What do you guys do? Like JavaScript or back? Go? All right, cool. I don't know what that is, but it sounds cool. Okay. So that's the typical thing you can see, and also you have like the this shouldn't happen moment. You realize that, oh, here, this could be null. I'm about to return null. Yeah, I'll just return it. I'll let the other guy handle it. No, but it's because returning null is like returning a burning bag of dog poop, okay? It's like if the recipient manages not to get burned, she's still left with like a stinky, disgusting object that now she has to handle. Okay, so don't be that guy, don't be that person that chickens out and returns null. Throw. If something shouldn't happen, if it's an exceptional circumstance in your application, why throw an exception? So aptly named, isn't it? So yeah, something doesn't exist, use optional. If it shouldn't happen, throw. And this is how you could. This is what the optional type would look like. You don't have this in C#, so you'd have to create it yourself. It's a super simple class. You ask it, does it have a value, true or false, and you do get, and you get the value. If you get, if is present is false, you get an exception, of course. So now I just want to mention that C# has something called a nullable, which you can use on value types and structs. And it's a way to be able to make like integers or strings or whatever value type you have be null. And it can sort of be used for this optional thing, like, yeah, I'm returning an integer or null. And it's not the same thing as optional. The purpose of this of the nullable pattern. There we go. Yeah, we're back. The purpose of Null is just to interact with sources that naturally return null outside of your control, like databases. It was specifically made for this. And maybe because a lot of people use Null to indicate that something is missing, so Microsoft wanted to please those. But you know, this is really just another way of introducing Null. There's more ways of doing Null right now, so don't do this. This is like Null 2.0, so try to limit this. You write your own simple optional class instead, it's easier. All right, so we talked about trust, domain-driven security, and let's talk about another pattern now that focuses on the trust boundary. It's called the Untrusted pattern, where you try to make trust a first-class concept at trust boundaries. The thing is that domain-driven security is great, you should all use it, but maybe your project isn't ready for it. Maybe you don't even have a domain model. Maybe it can be a major surgery, just converting all your objects, putting validation in there, and you have to do it step by step. So here's a good interim pattern that you can use, which zooms in on the trust boundary itself. So take this function, foo. It takes something, string, a bar, it's a string, it's an untrusted object, or a value. We validate it, and then we do something with it. And the do something with function is inside the circle of trust, inside the trust boundary. So the thing is here, we can't really see the trust boundary, right? It doesn't stick out. Sure, there's validation here. The validation is going on, so maybe we can assume that here we have a trust boundary. We can't really tell. So we want to make the trust boundary visible. So let's do something really simple like this. We just use a naming convention. Everything we know is untrusted. We put untrusted underscore before it. Really simple, really effective. Violates every naming guideline in C#, but you know, go ahead and check. What do you say? Turn off those warnings and use this pattern. So we just validate. When we validate it, we can just assign it to a bar, and we have a trusted object, and we're good to go. So it's simple because then when you have a function like this, you see, okay, it takes some 2 untrusted inputs, but what's up with this? This is like the naked primitive being passed around in domain-driven security, right? We know that we see something, and together with untrusted stuff that does not have the untrusted prefix, we probably forgot to validate this. Or if we validated it, we should probably clean up this function so it only takes either trusted or untrusted parameters. So this is good. This makes security code reviews a lot easier. We can do something like this to clean it up a little bit, have a validate function that takes untrusted and returns a bar. But the thing is, this is just naming convention. There's nothing here that forces us to do validation, right? We could just we could just pass untrusted to do something with and be on our way. That would be cheating. But can we do this? Can we lift up the untrusted concept and make it a first-class citizen in our code? Well, why not do something like this? We have a generic type, an untrusted box that we put our value in, and the only way for a client to get the value out is to do validation. That's the goal we want to achieve. So we lock our untrusted box, and the only way you can get out if you have the validation key, so to speak. So what might that look like? So here's how we could do this. Here's our untrusted of t. We construct it with a value, and then we have a getter for the value. Does anyone see anything strange with this getter? Anyone? It's kind of useless, isn't it? This is a private getter. How are we going to get this value out of the untrusted container? We can't. The only one that can use the getter right now is the untrusted class itself. So there's this thing in C# called an assembly is the packaging unit in .NET. It's like a jar file, basically, in Java. And assemblies can have attributes to them. You can set sort of metadata on them. And one of these assembly directives, as they're called, is something called internals visible to, where if I decorate the assembly that contains the untrusted class with this directive, it says that internals should be visible to an assembly called validation. That means that everything that is private private inside of the untrusted assembly will become visible in the validation assembly. So the validation assembly can in fact call the value getter here. So then meanwhile in the validation assembly, we can write a validator that looks something like this. You have a template method that does an validation. If it's not valid, you throw an exception or you return the value. Because then validation has been performed, you pull out the trusted value and return it. So implementers of a validator will then implement the inner validate method. Yeah, here you see that we can actually have access to that private value, right? Because we're in the validation assembly, and the internals of the other assembly was visible to this. So you do something like this. You write an account number validator that implements validator, and to get the value out of it, you just call validate, and if it passes, you get the trusted value out, and you're good. You don't see the exception is automatically thrown here if it's not valid. So that's pretty convenient. And the account number validator would, of course, just validate against normal domain rules. You could write a do nothing validator just to bypass this, but then at least you make a conscious effort trying to be I'm sorry, I'm just clicking away some antivirus balloons here. Sorry. Hang on. There we go. Yeah, so the only thing about this is, of course, you have to remember to new up these objects. There's a bit of glue code involved. I get that. You have to identify your trust boundary and do this little thing where you new them up. If you're using ASP.NET MVC, the web framework, you can write a model binder for this that automatically takes the incoming values and wraps them in untrusted, so that your controllers will then only have untrusted inputs in their methods. So then you don't really need the glue code. It will be done by a model binder. And before we leave the untrusted pattern, just want to ask, are there any C++ developers in here? Yes. All right, yeah. Cool, yeah, you'll be glad to know then that in C++ it's even nicer. You don't need this glue code because you have implicit constructors. So the compiler will find a way to create an untrusted if you just put it in the constructor. And you also have friend classes. You don't need the whole, it's more fine-grained trust where you can, how you make your types visible. So go ahead and try this in C++. So okay, that wraps up the untrusted pattern. A good pattern if you can't use domain-driven security, but you want to highlight the trust boundary. So we're moving on from the untrusted pattern to immutability. So I talked a lot about trust in the beginning and how that you need to validate something before you can trust it. But what if the data can be changed after we validated it, after we trusted it, when it's inside our circle of trust? Well, then we can't trust it anymore, right? Because we validated something and then it changed. So how can we trust it if it can change? So no matter if we go from the outside to the inside of our circle of trust, or we pass something out from our circle of trust to the outside, it's not supposed to be able to change, because then we have to revalidate everything again. And something that can change is a fancy word is immutable for that. So yeah, does your application handle concurrency? If you're running a web application, you have a lot of threads. How does that affect validation if your objects can change? The thing you just validated, is it valid, right? Because there's this thing called TOC2, time of check to time of use. And this is everywhere in code. You've all seen it without thinking about it, perhaps. Let's take a look at this function. Try transfer some amount. We check that our account contains that amount. This is a business rule, and then we transfer it if it's okay. So you have a time of check, TOC here, and a time of use right here. So what if this is a multi-threaded situation here, where another thread can come in right in between, right after the check has been done, but before the use, and change amount. Like if it said, oh, the account contains 100 euros, but another thread comes in and boosts us up to 1,000 before we do the transfer. Right? Then we are victims of a time of check to time of use vulnerability. So the way, and the most simple way to solve this is, of course, to make the amount object immutable. It cannot be changed. You set the value in the constructor, and then declare it as final or read-only in C#, and then this value can never be changed because we only have a getter for it also. There's no setter, which you cannot have when it's a final or read-only value. So super simple, but a great thing, because immutability, it significantly reduces these TOC2 problems. It plays very well with domain-driven security. In fact, you should try to make all your domain objects immutable as much as possible. It also plays very well with readability, parallelization, event sourcing, if you want to use that, etc., etc., etc. And so let's take a look at a practical example here of where TOC2 problem. If you know what a race condition is, raise your hands. Okay, that's almost everyone. Cool. Then you know that a race condition is when the outcome of something is dependent on the sequence or timing of events that are outside of your control. So it's typically like threads that race for access to some shared resource. And depending on who comes first, different things happen. So apart from leading to super hard bugs, this is a security problem as well. Let's take a look at why. So imagine you're doing a website. It has a small, like 3-step wizard, some sort of shopping cart perhaps. You need, it's the first step when you enter the wizard, you pick a product and then you check out. So we need some data to hold the steps that travel with this wizard. So we just conjure up this wizard data dictionary, which has a key, a globally unique identifier, which is the key for the current user, and some data object that holds the stuff that we need to transfer between the steps here. So it's a static, right? All you web folks, you shudder, you see the static because now you know some concurrency issue is going to happen. That's good. You're aware of this. But it might also be that this wasn't static. This could have been a singleton, perhaps, from your dependency injection container. Then this would just be a regular class variable. It would have the same effect, right? It would still be like a static. So just doing it static here for make the example easier. So okay, the user navigates to step 1. We create a new ID for the users, a new empty data object, just put in the dictionary. We return the key to the user so you can supply it in the query string, right, in the next, or the post data in the next step. Step 2, the user has chosen some kind of product, so we update his data with this product ID. And in the third step, this is like the checkout step, it's just a click on a button. And so we do a check if the user has access to this product. And then if she has access, then we do something with it. We ship it or whatever. So I indicated the time of check and time of use here. Now the billion-dollar question. Does anyone see what can go wrong here? Hands up. Yeah, go man. Exactly. The user can change the product ID between the time of check to time of use by issuing a step 2 call right in between here. Maybe the user has figured out there's another secret product that I'm not actually allowed to purchase or whatever, and she's sitting with a browser and going to step 3, and then simultaneously have some sort of script that does the wizard step 2, just bombards the application with the step 2 calls and see if, and tries this over and over again until the timing is exactly right, and the attacker is lucky and gets the step 2 right in between time of check to time of use. So, well, the solution, of course, we're talking about immutability. We do an immutable data object instead. First step looks the same. The second step, here's the difference. Since we cannot change the data object, we have to create a new one. Because it's immutable, we can change it. So we have some utility method that's called clone with product ID, because probably this data object has a bunch of other properties, right? So we clone all those properties, and then we create a new one with the new product ID. We set that in our wizard data instead. And step 3 looks exactly the same, but you still have the time of check, the time of use. You can't escape that unless you have some sort of atomic operation that does this, which you probably don't have. And but we're good because data can't change; it's immutable. So we eradicated this talk to problem here. Immutability. Just to sum up a little bit, it's great. It's like a magic security spray almost. You spray over your code, makes it smell nice and fresh. It makes it easier to understand and more robust, everything. And really, you should try to make immutability the norm, right? In your mind, your mindset should be that you should always try to make your objects immutable. Once they've been created, they shouldn't be able to change. And every time you have to make something that's mutable, that can change, you should feel a little bit bad and really try to contain this. And maybe you can refactor this object to have all the immutable properties. You can move to one object and just contain the mutable object in one nice place. So you can just poke it with a stick, and maybe one day you can just kill it off if you're not ready for that just yet. So you contain it so it doesn't spread, like the mutability. Okay, we talked about all this stuff: trust, domain-driven security, untrusted pattern, immutability. I have about 5 minutes left. That's perfect. We're going to be talking about something called the inverse life coach pattern. Be a pessimist, yeah. So, strangely named pattern, but before we can look at it, we have to look at the so-called life coach anti-pattern. Here's the life coach anti-pattern. You've done nothing yet, but you, my friend, you are a success. Okay? No matter what happens in bunch of code, I'm sure you're gonna be a success, and you know, even if you don't, I still charge you. It's great. So, you know, for some reason, the problem with this is, of course, that in the life coach pattern, if you, for some reason, erroneously exit somewhere in a bunch of code and return, there might be return statements in there too, of course, and you return your success variable, and you've forgotten or neglected or ended up on a weird code path that did not set success to false, you will return true, and your clients will think that everything was good. And this is more or less what happened in Apple's infamous go to fail bug about a year ago that I'm sure you heard about. So where the certificate validation on iOS and briefly on OS X was totally broken because of a simple thing like this, basically. And so you don't want to be the life coach, you want to be the inverse life coach. You know, you have not. Assume failure. You, my friend, you've not succeeded yet. You have to prove yourself here in a bunch of code, and maybe you'll be returned as a success. And also, of course, we're object-oriented, so we're going to use exceptions instead, and proper objects instead of just returning booleans. So be negative, be a pessimist, assume all the failures first, check them, and throw. And don't be a chicken, just throw an exception, you know, watch the world burn, why not? And at least you won't have a security vulnerability. We have a bunch of code, and then the only way to exit this function, except exploding in an exception, is to return a proper result data successful object. So you're enforcing like a narrow path of success. There's no success flag on result data. It's always a successful object. So the only way to exit in a bad way is by an exception, or the other narrow path which you should take is the successful way. Okay. So before I'm just going to wrap up now with 5 things that I want you to take with you in this session. First, identify your trust boundaries. If you haven't thought about this before, now is a good time to start. Look at your code and see, okay, here's where I put my trust. Here's where I shouldn't put trust, and I'm doing it. This is really helpful. Go through the code. And validation is the only way. And yeah, it's not that much fun to do validation, but use this pattern if you can. It's really easy and really a pleasant pattern to use. You have these validated domain objects floating around, which also hopefully are immutable, and you can just bathe in the glorious validation of it all. Immutability should be the norm. Try to make it the norm. Maybe you're sitting on today like a huge code base of mutable state, probably. But you know, the new code that you write, try to strive for immutability and slowly refactor the old code. The first step is to contain it. Like separate your objects into an immutable part and a mutable part. And then when you gather all the mutable parts in one place, you can just drop a bomb on them and then wipe them out. Okay. And when you see something immutable, you should just, you should cringe. It's like a virus in your code, right? So there's no other way of saying this. Null is a burning bag of dog poop. Don't return null. Don't be that person. And if there's something that's exceptional, throw an exception. Use optional to indicate that something is indeed optional. Don't return null. Don't give your clients a burning bag of dog poop. And last but not least, fire your life coach, okay? Coders, we don't need life coaches, we need inverse life coaches that tells us that, you know, you're not successful yet, you have to prove yourself, your code has to prove itself before it can return. It's a narrow path of success, it's like climbing a mountain, right? That's how you should think. Okay, thank you very much. That's my email address if you want to contact me, and there's about 30 seconds left, so if you have any questions, go ahead and raise your hand. If you don't want to ask a question now, you can talk to me later. I'll be here all day. Okay, thank you very much. Thank you.